just combining more rules. Okay, are we ready? 8b. So fractional indices. We want to be turning things from fractional powers into surds. Okay, so if it is 1 over some number, that number on the bottom of that fraction is the type of root. If it's a 2, it means it's a normal square root. If it's a 3, it means it's a cubed root. If it's a 4, it's a fourth root. Okay, whatever that number is the type of root. Does that make sense?
Yes.
If there is a number on the top of the fraction as well, not just a 1, a number other than a 1 I should say, on the top of the fraction, then that number comes underneath with your base. So it is a to the power of the top number, m, and the number on the bottom is still the type of square root. So it's still, if it's a 2 here, it's still a square root. If it's 3, it's still a cubed root. Okay? That can be written as whatever type of root that is in here of a, and then all of it, all of the whole thing can be to the power of whatever that top number was. Okay? All right, let's practice it. They're the laws, the rules. Example number 1. Evaluate each of the following. Now, as much as possible, we're just practicing using our square root form. I'm not expecting, I know you can type stuff into your calculator, okay? But we're trying to familiarize yourself with what these fractional powers mean. So a power of a half, you should automatically be thinking that that is the same as a square root, a normal square root. The square root of 4 is simply 2. You don't need a calculator for that, okay? So part B would be the same. A power of a half means that that is a square root of 100. And the square root of 100 is 10. Part C, see the 3 on the bottom there? That means that it's now become a cubed root of 8. Now, with a square root, you notice you never have to write the 2 on here, but any other type of root, you have to write the 3 if it's a cubed root, or 4 for a fourth root. Okay? So it's a cubed root of 8, which means 2 times 2 times 2 makes 8, which means the answer to that is 2. Part D. Now, be careful with these. Sometimes the little minus signs are hard to see. That's actually a power of minus a third. Can you see the little minus there? So whenever you have a minus there, deal with that first. That means 1 over 125 to the positive power of 1/3. That's a bit small. Can you see that? The positive power of 1/3 means the same as a cubed root of 125. Now, the cubed root of 125 is 5. So that is 1 over 5. So as much as possible, use your laws to try and help you work these out. If you do need your calculator to help you cube root something or square root something, that part's okay. But just practicing changing from fractional powers to surds, please. This one, however, does say evaluate on a calculator correct to 4 decimal places. So you can type that in with the fractional power, or you could try it with a 6 root if you wanted to, because it would be the same thing. So the fractional power would be 34 to the power of, and then you type your fraction button in there, 1 over 6. Okay, so you get that number. 4 decimal places would be 1.7999. Or, just for fun, a 6 root, that's the square root button. You press the shift and then that one to get that. And you can put any power square root that you want in there. So 6 root of 34 and get the same answer. Okay? Either form, fractional power or square root form. So try the next one. Type in either 300 to the power of 3 over 8 or the 8th root of 300 cubed to 4 decimal places. Yep. Okay, question 3 says to simplify. It does say without a calculator. That means that you're showing how you're manipulating these, but you are still allowed to use your calculator for small multiplying things if you need to, okay? So 64 to the power of 2/3. What we can do with that is I could change that to be 64 to the power of 1/3, because if I'm doing this in my head, I know how to cube root things. Well, I can cube root some things, but 2/3 is not quite so easy to do. So that's a cubed root, and then the 2, I move it outside the bracket like that. So together, that does make my 2/3, but I could do this. I'm much more likely to be able to do that part in my head, right? So the cubed root of 64, I'll write that down. So that changes to a cubed root of 64. That's all going to be squared. And the cube root of 64, does anyone know it?
4.
Is 4. So that's 4 squared, which equals 16. Okay, let's try the next one. Same principle. So it's 25 to the power of 3/2. So let's change that to be 25 to the power of 1/2. So splitting the fraction part out and bringing the 3 outside the bracket. So that power of 1/2 is the same as a square root. And the square root of 25 is 5. So it's 5 cubed, which is 125. Okay, can do it with fractions as well. So we have 4/9 to the power of 3/2. So let's keep to our process. We're going to have the 4/9. We're going to put a power of 1/2 out there. And then I'm going to need a second set of brackets for my power of 3 that needs to be outside of that. Okay, now that means that the power of 1/2 inside means that I need to square root everything. So I won't rewrite it as a square root. You're okay with the power of 1/2 as a square root? So if I square root this bracket, I square root the 4, which is 2/3. That's square rooting everything. And now I need to cube everything inside there. So 2 cubed is 8, and 3 cubed is 27. Yeah? Okay, another one. 16/81 to the power of 3/4. So we're going to keep the 16/81. We're going to make that to a power of 1/4, and that needs to be cubed. Okay? So this is where you might want your calculator. Let's see. The 16 to the power of 1/4 means a 4th root of 16. Anyone know? 2, good. And 4th root of 81? What do you think? 3. It's pretty easy to guess them actually, because there's not too many options that can give that kind of number. All right, so then I need to cube everything inside there. So 2 cubed is 8, and 3 cubed is 27, which amazingly got the same answer as C. All right, yes. Now to go backwards. I have got my questions in surd form, and I need to write them in index form, meaning fractional powers. So a square root is the same as a power of 1/2. So that's 15 to the power of 1/2. That's it. That's all I want. Okay, same for B. It's a square root. So that means it's 7 to the power of 1/2. Easy peasy, right? Let's put a few more things in there. Part C. I have a square root, which means all of that, the 3x to the power of 7, has to be to the power of 1/2. Okay, now if the 3 wasn't there, I might have been able to do some more things there, but I can't for that one. Part D. The 5 is not part of the square root, so it's going to be sitting at the front. The A, remember the type of square root, it's a cubed root, is going to be the bottom number of your fractions. There's going to be a 3 on the bottom. And the power underneath the square root sign goes to the top. So it's a power of 4/3. That's it. Part E. 5√5. Now the 5, I've got a whole number 5 out the front. And the square root of 5, a square root is the same as a power of a half. Now, both of those numbers, though, are bases of 5. So that first one would be 5 to the power of 1. If the bases are the same, then you can add the powers together. 1 plus a half is 1.5, but we don't use mixed numerals when they're powers. We turn them into improper fractions. So it'd be 5 to the power of 3 over 2. And one last one. First of all, I deal with the third part. Okay, so the x is the base. It's a cubed root, which means a 3 is going to be on the bottom of the fraction, but there's a 5 underneath, which means it's a 5 on the top of that fraction. Yeah? Now, the other thing that I can do is to give that a negative power, so that's completely simplified as much as possible. I could change that to be x to the power of negative 5 over 3. Okay? Now, this is extremely important that you get comfortable with moving your indices around. It's going to help you not only in this topic, but in our next topic of differentiation. The differentiating is often not the trickiest part. It's having to rearrange things into forms that you can differentiate using your index laws. So please practice.